So today, let's take a look at this EGO 56-volt light. This light was sent in to us by Rickstrew, and he graciously sent this in and paid for the shipping just so we could look at it today and hopefully have a successful repair and learn more about it. We also had a 5 amp hour battery sent in that we looked at in the last video if you want to check that out as well. So this is what the box looks like. And let's go ahead and open it up. Packaged up very well. Steven sent this in because the light failed. EGO replaced it under warranty. So he removed the tag or label, as you can see here. And EGO usually informs you to just recycle it. So he just sent this in so we can look at it, at least learn more about it, and possibly repair it. I'm very impressed with the build quality of this light. The handle, the way it hinges, a lot of thought absolutely went into this light design. Got a helper here. What's wrong with it? Sniff out the problem. What's wrong with it? What's wrong with it, Harvey dog? What's wrong with it? Let's go ahead and throw a battery on here and see what it does. Yeah, power on. No other button seems to do anything. We also noticed that our battery light does not respond to any other push button, including the power on. We do have our joist or rafter hangers. Those are pretty neat. We also have our 1/4 20 and our 5/8 11 threaded inserts for our tripod mount. Would absolutely be a handy work light if we can get it working today. So let's put it on the bench and let's look inside. We're going to be using 2 of our security Torx bits. It's going to be T10 and T20 security Torx. So that is the Torx with the little stud in the middle of the head of the screw. Start off with the T10, smaller ones around the edge and here in the middle and around the top edges. Going to fast forward through a lot of this. And then the T20 for our larger 2 here on the outside bottom. And there's our bottom plate. There's our push button assembly. That wasn't quite what I was expecting. I guess I thought the board would be under here with it, but it actually feeds through to the middle. So we got our smaller screws that hold this base plate on. Also have a bracket here that's holding this push button assembly on. Same screws so far. These 2 larger screws on this bracket for our hangers. Go ahead and remove these. It looks like we got to remove them at least to get to the push button assembly here. The rubber membrane is staying. I guess you can push it and bring it all out, but there's our push button assembly. I guess we can see it better this way, really. So we have a ribbon cable and a red and black going through our iron ferrite core. Before we go too far, let's go ahead and own the push button. This would be an easy repair if the power button wasn't getting any feedback of being pressed, but we wouldn't need to go any further if it's just right here. So definitely showing a pull up or pull down resistor there, and then yep, 0 ohms. We definitely have continuity there, so the button is good. Let's go ahead and put a battery in it, and I did not try the USB. Let's see if we have the 5 volts to that, and it's not looking like it. I really don't know if the light has to be powered on to see that 5 volts. More than likely it does. Yeah, sorry, some of that display is off camera, but yeah, it never lit up. Obviously no 5 volts there. I've got to say I've always been impressed with EGO's latch and battery release system, and in this case they have used this spring for the battery release to also be a covering for the battery contact slides, and I really like that. It's got a good spring loaded latch and a heavy spring release. So all the screws are removed on this base plate and it should come off, but it's probably going to be pretty tight, and there we go. So with that Fire-Right sleeve pushed down, we should be able to slide this push button assembly and the ribbon cable through the opening. And there we go. So that's how they designed that. And then here's our controller here, and boy, it sure is potted. That's actually a thermal pad right here. But yeah, under that thermal pad, it's definitely all silicone potted for sure. Not going to be a quick job looking at this one. We have some #1 Phillips here. Remove these right quick. It might be a little bit quicker to get my little mini screwdriver out. It still has some charge to it, I'm sure. Let's just go ahead and get these 4 screws out. Might have to help it a little bit here, but it got it. And we have 3 connectors. One larger connector that seems to be caught up, but it actually has release latches. I didn't see that. So the lower part of these has a little locking mechanism, a little latch. So that's why that one didn't want to pull out easy, and releasing that latch does a trick. That is one potted rascal. I'm going to start digging and just see if I get lucky and come across a fuse or something obvious. I don't see any dark marks looking through the silicone other than what seems to be top of maybe capacitors sticking up. Obviously we see our large square inductor sticking up, which surprisingly that thermal pad is only going to try to conduct heat like right there. So I just wonder about the thermal design with this being so full of silicone and not much to dissipate. I'm going to use my newer plastic pry tools here. Even though I know plastic is better on some things, it's hard to get plastic to sharp enough to cut through easily, and I do find myself having to push the plastic harder through silicone with that resistance than just a fine, thin metal one. Sometimes I think I can cause more damage with plastic myself than I do metal, because the metal just gives me a better feel of what I'm touching. And is what I'm touching really spongy, or is it solid like a component or the board? But we already do see a problem here. This is a dark spot right here. It was a smoked up spot on the bottom of that white silicone. Looks like a really small SOT 23 style device. A SOT 23-6 6-pin. Yeah, I'm going to get my metal screwdriver out here that's really fine. Get around these small components to help sometimes. There's that black spot again from that component. You can see that. So we do have some issues, as well as a bulged cap. You may can see it on camera, but the cap that's right beside that inductor is bulged, so possibly overheating there really close to that inductor is hard to say, but for sure it's at least a possibility. I'm going to use some 99% alcohol to hopefully get the board to release a little more of the silicone. I'm going to spray it in here and let it soak for a few minutes, and it's also going to run down and hopefully make it easy to release out of the encapsulation. I know it's at least more than one board, because you can see the back connector board through this plastic housing as well. So I'm just going to take some time here to work this alcohol in and just hopefully get where you can read the components better on camera. We do have 2 #1 Phillips in 2 corners here holding the board in place. And with that alcohol running out of the back, maybe this will release. And it did move. As aggravating as silicone can be, at least you can work with it. EGO does epoxy feel some things, and it's pretty much done. Not much you can do with epoxy without damaging the whole board and components. Well, I got a lot more work to do. It's at least 2 boards here. So back now, I have more silicone than looks like I actually fit in the area that I removed the board from, but I do have a good portion of it removed. You can see a little bit better here already. The backboard is not much to it, but connectors, a few components. This looks like our main control board with some probably control power and a microcontroller all in one here. We see several issues. We're going to take time to desolder the boards from each other. I got this little desoldering gun that works pretty good for through holes. Just a little bit of patience here to get the solder to melt around the pin. And once you feel it liquefy and you're able to rock it around, you just pull the trigger and vacuum most of that solder out of the hole. It's probably not nearly as nice as the Hako, but for no more than I use it, this cheap one has worked pretty well for me. Just going to fast forward through a lot of this. Our holes are clear, but we are stuck, and I do believe most of that is silicone. But just for insurance, I'm going to go ahead and take time to put some low melt solder on the joints. And we use the low melt solder a lot on this channel for just an occasion. You work this low melt solder in and it stays liquefied for a while. So this just gives me a little bit of a guarantee that my pads won't get ripped if there's something underneath that's still grabbing that I can't see. We'll just make sure we take time to work this in, and I'll show here just how long this stuff stays liquid. So it really gives you some time here to work with it, which is really handy. I'll just keep making sure this is liquid and it's flowing down through the pins well. And then I don't mind prying against the silicone. And just like that, we're off. And you can definitely tell that the silicone is what was holding there, and it's totally broke free, at least on this end. Let's do the same thing on this end. Just work the low melt solder into the pins well. And then I can just take my little plastic pry bar, which that taper works out great. Just kind of using it as a wedge to push up gently. And there we go. So this bottom board looks like it's going to be our driver board for our 4 LED modules. This looks like our main control board, and also has our control power and micro and the interface to our I/O push button assembly. Let's go ahead and just check this fuse, and this fuse is good, so more than likely this part of the board is okay. So back now, I have cleaned up a lot more silicone, and I've taken some solder wick or braid, and I have cleaned up the holes and removed all the low melt solder that was residual. And there we go, everything's fairly cleaned up. So we're just now getting to the point where we can kind of troubleshoot. We got a little board that turns down to a 90-degree here, which is a little bit odd. Looks like a transistor. It may be some type of sensor, I really don't know. Looking at our control board here, we definitely see our cap that's bulged by our inductor. We can definitely see this 6-pin SOC23 device that is blown. Our 8-pin that's totally missing and seems to be just desoldered from the board. I mean, no legs are there, it's just gone. And we have a 3-pin, what looks to be a transistor, also SOC23 device that I possibly could have damaged with the pry tool, but it is odd that only one leg looks like it was ripped. The other two look like it really did get hot enough to just release it. So we got to learn a little bit more about this board and see if we can possibly find these components, if there's any reference available for them. This is a close-up of what I'm calling our LED driver board. It has the 4 individual driver outputs, it seems. 5-amp fuse, large cap. Not a whole lot to the bottom of this board. A little bit more detail on that little 90-degree board there. I guess I just don't understand the thermal dissipation design of it. It's not really a lot of places for the heat to go. Whether that caused this failure or not, I can't be sure. Just wondering. The bulge cap could be from something else, but sometimes you see that with a cap really close to an inductor or a heat sink of some kind, and just kind of looks to be obvious. So we're going to see if we can find these components and go any further with this. So I cannot find numbers on these components due to damage, and the ones I can see I have no information of. So I'm going to see what I can find out and post this on the Facebook group on the bench and just see if anybody else has had to look up similar components and see if we have any luck. Meanwhile, let's look into the LED modules just to make sure they're in good shape and test good. and that it's worth going further with the repair. Let's just go ahead and take this main LED assembly off. We have a good gasket, and there's our module. This is going to be where a lot of our wiring is, because we have our connector for the battery and all behind here as well. And okay, it looks like we can just take these Torx, maybe the same Torx screws here on the edge, 2 on each side. We're not trying to take the LED board off the heatsink at this time. We're just trying to get the whole module out. And so this is our yellow and white wire. I'm going to document what wire is which on these for our reference, if it's helpful to anyone in the future. I do like the way it connects up. They have potted the area very well to keep out moisture ingress, which sometimes can be a double-edged sword. I mean, you're keeping water out, you also got to get heat out. We see that they do like using these iron ferrite cores to help with spikes. I don't know if they had issues with initial design or that's just preventative, but either way, it shows a lot of design and engineering. I'm going to go ahead and unplug this module and we'll test a few LEDs. This cable here, it really did get pinched. Yeah, it got pinched very hard. Nothing seems to break the insulation, but it just got across here in one of these spots and got wedged between the heatsink. It's not good. We'll try to make sure we route that a little differently, putting it back together. But the cool thing is that's just like a jumper from the board to the light. So that could be easily replaced if it is damaged. I'm going to take my meter and diode check function, and looks like it's around this way. And yep, there's our LED. Checks good. Checks good. I was having some mic issues. I didn't realize it. So I'm hoping this will be better. I do apologize. So my meter is showing OL or open loop because my meter can only put out around 2.4 volts in diode range in this meter. So our forward voltage on these LEDs is absolutely going to be higher than that. Just go across and check a few more of these LEDs. But at least we can test them out and make them at least fire. This is a super nice LED module. The heatsink is massive. Probably because it's got to be in the housing closed and sealed up like that. So I'm going to bring over my power supply. I have my supply set for 24 volts, 0.1 amps. So I do have a constant voltage and constant current supply, so no higher than 24 volts and no higher than 100 milliamps. It barely fires the LEDs, but it does light them all up. And these LED modules not only look good and healthy, they are healthy. So if I take this up to 24 volts and 0.2 or 200 milliamps, we're definitely getting some brightness there, but nowhere near full potential for these LEDs. So we can still be safe here and go up. We don't want to go over 29 volts because I doubt these are 30 volt modules the way they put together. But I will go all the way to 200 milliamps at 29 volts, and we should be well within that 29 volts on that limit of 200 milliamps. And that does light it up very bright. Nowhere near full intensity, but it is very bright. So nice. I probably should zoom in and give you a little more detail of these LEDs. We do have some 0 ohm resistors, probably using these for like a SMD fuse, and the little caps that's in parallel with each individual LED. And you can see here that these LEDs are in series across these rows. Like if I check this one across this cap like so, we see that it's good. Now it goes over to this one, so if I go here on this side of the cap, you'll see it still lights the one in the center here, because it goes across to that one in series. And likewise here we go over to this one, not on this side but on this side, because they're not in parallel, they're in series across these rows of 6. Let's go ahead and put this module back in, and we'll take a brief look at the others as well. Just going to go ahead and put our 4 screws back in the heatsink, 2 on each side. Line up our gasket on our lens or diffuser. And there we go. It does fit nice. And this only goes one way. It's got to go on this stud right here. And there we go. That's a good seal. Put it back together. We have 8 screws here to put back in for what I'm calling the main LED module. And that gasket looks good. So we know what the yellow and the white is. Then we got several more to figure out, and we'll document those as well as we go. We got 8 screws in this one as well. Go ahead and remove those. Probably go ahead and remove the ones on the hinge as well, and it wouldn't hurt to go ahead and remove the upper middle module. Go ahead and remove the handle to get it out of the way, and then the other 8 screws. And there we go. It's a lot easier to flip this over. Still 6 in a row and 5 rows. So all of these are going to be the same as I did suspect, but I didn't know that for a fact. So we do see a lot thinner heatsink, just aluminum plate it looks like on this one, and it does have cooling fins on the back, but they are plastic. I don't really know how well that works, but that's not really my thing. But hopefully they will cool just fine. And on the other module, yellow was positive and white was minus, and the wire color on this one is gray and orange is going to be positive. On what I'm calling the upper right, as you face the light, we'll put all this back together after testing. This one obviously has a gasket also. Put all the screws back in, at least on the panel side, and then we'll flip it over and remove the center. And this upper mid module, I'm calling it, it has white and blue is positive. We'll test it out really quick. Same number LEDs, same module, and there we go. We'll put the screws back in this, but one thing worth mentioning here is almost all of these T10 head screws are the same, but the ones that go in this hinge are shorter. So I didn't mention that, but you don't want to grab one too long. It'll probably poke through the other side. That's the only 4 shorter screws that I know of that's in it so far. It's the 4 that's in the hinges. Let's go ahead and put the other 8 back in here. And by the way, the upper left module was the same. It was just red and white, and red was positive. So we'll just cut through that in the video. So in this part of the troubleshooting, I want to mention that I started looking up spare parts for this light. Whether I needed to buy another broke one and take a chance on what might be broken may be different, or just buying another light. I was at least pleased to see that looking up parts, some places do have these parts available and have the parts breakdown. So like this one, Cutler's, it was a little more expensive here. They had a good breakdown. They're calling this the main electric assembly, 283-114-1001, and I did end up ordering one from RCPW. It was around $60 including shipping, so about half the price of the light. So this repair is not going to be for everybody. Everybody's going to be different. Is it worth half the light to buy the module? Obviously for me, hopefully without saying, it's about learning more about the light, and not only can I get the light working, but also hopefully be able to use the testing of the working module to give us some needed information for not only the LED modules, but of course these SMD components that I can't find. So just hoping to get lucky in that. And this item was back ordered, but I did tell them I wanted to wait for it, and it actually didn't even take a month to come in, so it really wasn't terrible. Just kind of glad the part was at least available, and I am seeing a lot more EGO parts available, like blower controllers. They used to not really be available when I was searching years ago. They are pricey, but at least they are available if somebody does want to go that route. Or just like me, you may want to learn more about it when you get the new working one, and with that information you may could even get the other faulty controller going, for example. But it did come in, and let's see if we can get this light going and get some much needed testing and data points here. So here it is, and awesome. Just plug it up, see how it does. So remember, our second button from the USB is our power. So let's just get the rubber push button membrane and see The one closest to the USB is less intensity, and then it's our power, and then brighter intensity. So we're going to hit that button there. Once we get a battery, let me get the battery pack and we'll be right back. Alright, back with the battery pack. And by the way, I have marked these battery terminals so we know what they are. I'll have that down on the information sheet as well if somebody finds that helpful. Let's open this up a little bit so we can see the LEDs better. Alright, the second button, and there we go. That's our mid LED, and that's our intensity, and this is our mode. So we can cut them all on or just the middle. So it looks like no other button will make the light fire on, so it looks like it's going to have to be power. So honestly, if something did happen to that push button, it really would be dead as a hammer for something that simple. All seems to be working well, including the one I'm calling the mode switch, the mode toggle. I'll need to fast forward through some of this because I'm just playing around with it, having a little bit too much fun there. So I want to mention here, before I put the light back together, I did go through and do some testing. I looked at the voltage like so with the EGO controller, putting out the brightest intensity. I did also take time to go in line with current, and the max current we were seeing was right at 490 milliamps, so a little bit less than half an amp. I did step through and document a lot of these current readings if you find that helpful. I also did take time to take the old board as a reference where the components were located, and I did take extra time taking this silicone off of this new module, and that way I could get the proper part numbers and eventually even troubleshoot if I need to, because some of these part numbers I still have not found yet. I think they're custom or specialty chips made for Chevron. So I'll put a lot of this troubleshooting and information in another video because this one has gotten to be over 25 minutes. So for those that are interested, I'll have that information in another video. And those who don't care about it don't have to watch all that as well. One thing to mention here, it's kind of like a blooper that sometimes I would just take out of a video for time restraints. I thought this one was actually worth leaving in because not only was it kind of funny, it also might help somebody else. As I'm trying to troubleshoot at this point on this light, as the module slides in, the light cuts off, and I'm worried that I may let a wire hit on the sharp edges of the heatsink in there or something like that, and I thought maybe something shorted out. I could pick the module up and it comes right back on. And I'll probably fast forward through some of this, but I'll show the footage. It seems like the electric assembly is far enough away from the upper LED module that there's nothing that could be causing that. But after I've done this several times, and every time I push it in it would cut off on me, I was like, I don't think it's the wires. Is there any way it could be something like a magnet? I think it does have the feature of when you close the light down it will cut off, and I didn't see anything in the hinges that would actually do that. And then I got to thinking about that board, that 90-degree board that was on there, and then I took a magnet and yeah. So just playing around here, you can tell it won't come on. Remove the magnet, then it's on. Apply the magnet back and it's off. So I just didn't think it was that strong. The module is actually a good ways away from where that sensor is, and I didn't think the sensor went down that far, but it does go down a little ways. That's still a pretty strong like Hall effect field to pick up that well from that far away. That's pretty good. Anyway, I thought that was interesting. So to finish up this video, let's just put this light back together and we'll just prove it operational at the end, with hopes to learn more and maybe even repair the old module in another video. Put the 4 screws back in our electric assembly. We do have our thermal pad on the assembly. We're going to have to push this iron core down so we can turn our push button assembly to slide through like so. And there we go. Then we can push our fire right core through, and this should go down flush, and it does. We can actually angle this any way we want here, use it to our advantage. I'm going to take the little push button membrane and push it on there ahead of time because it really don't want to go in there at that angle without being all together, and that seemed to fit better. We do have to take this little rubber cover for the USB port and push it in a small groove in between the USB port and the rubber membrane pad, so it'll go back and forth, and that should go together just fine. Going to push our Firite core back down and get our wires in the groove. We'll put back on this little bracket that holds that assembly in place, and that does fit flush. All that seems to be working just fine. We'll go ahead and put our other T10 screws back in this bottom base plate. We'll put our joist hooks back on here and our brackets for them. We can put in 2 of these larger screws, but I forget which ones. Okay, it's the inside, so that was wrong. We can put them on the inside like so. Before we actually tighten it down, we can put our little spring-loaded bumpers in the corners here. That's to keep our panels in place when we fold them into the light for carrying and for storage. Push them in and make sure the springs stay in. We can go ahead and tighten up these 2 inside T20s. I believe you could leave this lower left one on here the whole time, but I had taken both of mine off because on the right side you got to take it off to remove this push button assembly anyway. Just thought I would mention that you could probably leave that one on the left if you desire to. Make sure we do have our springs there, and we can put our very bottom plate on here. And there's our T20s. And then we have 8 of the T10s. We'll zip them in there really quick. Really quick with the help of fast forward. And there we go. Everything seems in good working order. And that's what those little spring-loaded little catches do right here when you fold the light up. They do really catch well and hold. Another area that they put a lot of thought into that did work very well. And let's see, would the handle forward will the battery go in? Absolutely. They thought about that as well. And there we go. At least we did get the light working. It wasn't exactly the way we intended to start with, but when you can't find components, you can't find components. So I'll take it. It is back working. And I definitely plan on posting another video with much more information on the LED modules and their voltage and currents for possibly driving them other ways, obviously. And then of course any troubleshooting help with measurements on the new main assembly board compared to the bad one. Maybe we can figure out what some of those components are. Thanks again to Steven for sending this in today and just helping the community learn more about the light, because I personally hadn't owned one or worked on one prior, and it was a lot of fun to look into today. So I hope you found this video helpful today. If you did, please like, share, and subscribe. I'm going to have some links down in this video description of some tools and interesting things that I find helpful on my workbench. So those links are affiliate links, and any link you click on helps support the channel, and I greatly appreciate it. So thanks so much for watching, and God bless.